on section 2, day 2, I have, again, 2 more concepts for you. Okay? One of them, we're going to deal with something that we just did a little bit ago, where we're finding the vertex using that negative b over 2a thing. And then the other one is going to be just one more type of form that you can see the graphs in. Okay? So the first thing that you're going to look for, or the first thing that we're going to have on this part, is going to be minimums versus maximums. Now, before we even go into talking about what minimum and maximum really is, just because of the wording, what do you think it means?
We're going to have a range.
What do you think a minimum is? The lowest amount. What do you think maximum is? The highest amount. Think of it in terms of parabolas. The minimum amount would be the bottom of the bowl. The maximum amount would be the top of the bowl if it was flipped over. Okay? So if you've got one that's been reflected, you should have a maximum. And if you don't have one that's flipped over, you should have a minimum. So when they talk about that, here's how you find it. See if that makes any difference to you. It's x equals negative b over 2a. We just did that. All right, we just did that when we did the first day, when we found the vertex, right? Then to actually find the minimum or maximum values, you plug in x and solve. Or simplify if you want me to say it that way. What is this doing? It's doing the same thing we did when we found the vertex in standard form. It is the exact same thing. The only thing that you will need to know is whether or not it's a minimum or a maximum. And just so that you guys know, if it's a minimum, then the only way that that's determined is when a is, gotta remember this right now, minimum would be, so a is greater than 0, and if a is less than 0, it'd be a maximum. So all you're going to do is look at what number is in the a position, and that should tell you if it's a minimum or a maximum. And then we run it through just like we found the vertex the last time. The other new part that's going to be included on this is going to be increasing or decreasing. Okay, what side of that is going to be increasing and what side of it's going to be decreasing? So let's do one so that I can show you. If you have f of x equals 1/2 x squared minus 2x minus 1, the first thing it's going to do is it's going to ask you to find the minimum or maximum value. It's not going to have both. It's only going to have one of them. It's either a minimum or it's a maximum. So, look at what number's in the a position. It's a half. Is a half bigger than 0 or less than 0? Try that again. If I'm at 0 and I'm at half, is half bigger than 0 or less than 0? Bigger. Right. So if it's bigger than 0, our parabola should open up, which means we have a minimum. Okay? So we know we're going to have a minimum. So we know that off the top of the bat. Now, as far as finding it, what number is in the b position? Negative 2. Divided by 2 times what number is in the a position? Half. So on the top, 2 negatives make that a positive. And 2 times a half on the bottom is what? 1. And what's 2 divided by 1? 2. Now that's not the minimum or maximum. That's the x at which it occurs. You have to find the minimum or maximum, and what you do there is you plug that number 2 into your equation and see what we get. So 1/2 times 2 squared minus 2 times 2 minus 1. What is 2 squared? 4. What is half of 4? 2. What's negative 2 times 2? Negative 4. What is 2 minus 4 minus 1? The minimum value is negative 3. Here's the thing that you don't have to do. You do not have to graph this. Okay? However, I'm going to show you what the graph looks like very quickly, just to get the increasing and decreasing pieces. You told me it should open which way? Up. So if I were to make that graph go at 2 and negative 3, I'm somewhere in this category, and I'm hitting it somewhere in this thing right here. Now, here's how it works for the increasing and decreasing. Remember yesterday we put this axis of symmetry right down the middle, right? Pretend you're on a roller coaster ride, because I'm sure everybody just about has been on a roller coaster ride, or if you haven't, you've seen one. You're coming down the hill. Everybody's screaming, arms up. Is that increasing or decreasing?
Decrease.
You're decreasing because you're going down the hill. Yeah. And when you hit this bottom point, then you turn around and go what? Up. So therefore you are increasing. So how do you show that? What is the x-coordinate where it turns? 2. That's the x-coordinate where it turns. So the increasing part versus the decreasing, it increases when x is greater than 2, and that's really bad because you guys can't see that. It increases when x is greater than 2. And when does it decrease? When it's less than 2. When x is less than 2. That's what it means to do the increasing and decreasing. Now realistically, at this point in time, you're only going to have one increasing and one decreasing. That's it. Depending on which way the parabola opens. If it opens up like it does, it will start by decreasing first, then to the increasing. If it opens down, it will start with increasing and then go to decreasing. What do you think? Now, you don't need to put the graph on there. That's not part of the answer. I did it just for a visual representation of what was going on. If it's going to open up, it's decreasing first, then increasing around whatever the x is. If it opens down, which that would be a maximum, then it would be increasing first, decreasing second. Do you want me to do another one?
Yeah, do a maximum.
Okay. Let's see if I can find one. Let's go g of x equals negative 3x squared minus 6x plus 5. Okay, first things first, let's find the x. What number's in the b? Over 2 times what's in the a? Two negatives on the top make it a positive. And on the bottom, what's 2 times negative 3? Negative 6. And what's 6 divided by negative 6? Negative 1. So that is, right now, the x-coordinate. That's the turning point. Okay? Then as far as the minimum or maximum value, plug in that negative 1 into your equation and let's see what we get. Again, if you use your calculator, you could type the whole thing as it looks and it should give you the right answer. But if I don't have a calculator on me, negative 1 squared is 1. 1 times negative 3 is negative 3. Negative 6 times negative 1 is positive 6 plus 5. Negative 3 plus 6 is 3 plus 5 is 8. For those of you who typed it in your calculator, did you get 8?
Yes.
Good. Now, is 8 a minimum or a maximum? It all depends on this right there. Realistically, if that's a negative, it should be a maximum. And if it's a positive, it should be a minimum. Don't care how big the number is or how small it is. So because it is, it's a maximum. So then just label it as 8 and then just put max there so that I know you know that it's a maximum. Now, if I were to graph that, you don't have to. But if I were to graph that thing, I would have the dot way up here and I would be something like this. That's how the visual representation would be. If you're on the roller coaster ride, which I'm sure you guys have done, maybe. I don't because I would puke. But am I going uphill or down? Am I increasing or decreasing right now? Increasing until I get to the peak, and then what? Decreasing. So I am increasing when x is less than -1, and I'm decreasing when x is greater than -1. And all it means by less than and greater than, less than means left, greater than means to the right. That's it. Now, if it helps you to draw the picture, I'd suggest drawing the picture. It helps me. If it helps you, draw it. It doesn't take that long to do that. You don't have to make it that accurate, just as long as you know that it goes like this, so you know which side's increasing and decreasing. Half the assignment today is like this. What do you guys think? Again, you're not expected to graph that. Okay? Then, the last type of formula that you guys are going to see is you're going to see it when it's like this in this position. A, x minus p, x minus q. Okay? What this particular format is called is it's called the x-intercepts. The x-intercepts are p and q. So I want you to think about x-intercepts. If I give you x-intercepts and I'm showing you that there should be 2 of them, you know what that means? I'm giving you 2 dots on your graph. That's what I'm giving you. I'm giving you 2 of the dots out of the 3 that you need. The one I'm not giving you is I'm not giving you the vertex. That's the part that I'm not giving you. But the nice thing about this, because of symmetry, the vertex and the axis of symmetry are found by first starting out that x is equal to p plus q divided by 2. What does it mean when you take 2 numbers, add them, and divide by 2? What are you finding? The mean. All right, I even actually said it when I said the mean. Right, what does it mean? Mean?
Ha ha ha. That was so funny.
Not really. Wasn't meant to be. Or the average. That's what you're finding. The vertex should be, or the axis of symmetry should be right in the middle of them. In order to find the middle, you find the average. And then to get the y-coordinate, what do you think you do after you have the x? Plug it in. Yep. To get the y-coordinate, plug in x. Okay, so what I'm giving you with this is I'm giving you the 3rd form. Yesterday I gave you vertex form, and we talked about some of those at the beginning of the day. Then I gave you standard form, which is the ax squared plus bx plus c. And then this is now the 3rd way of doing it. Zane.
X and what?
X equals, or x-intercepts, you mean? Where?
Oh, that's,
Okay.
When do you use like this form compared to like?
When they're in, so how do you know which form to use? If it's like this, oh, not P. If it's like this where it says y equals, and it's got like a number here and then x minus a number here squared plus this, that's vertex form. Because that looks like the a x minus h plus k. If it had something like this where it says 2x squared plus 3x plus 7, that's standard form. Use the negative b over 2a thing. If it's in this type of format, where it has negative 2, parentheses, x plus 3, close it, x minus 1, now this is the intercepts method. Okay? So the question was, which one do you use when? This is vertex form, or one like it, so you'd use that first thing, where you're pulling the h and you're pulling the k out, and then plugging in a random number. This one is the standard form, so that's where you do the negative b over 2a thing, plug it back in to get the y, then pull the vertex out. This is the intercepts form, when you have two things multiplied together like that. So I'm going to take that one and I'm going to put it on a different slide, just so that we can actually do that one. Y equals negative 2, x plus 3, x minus 1. When it's in this form, here's what you start with. Set each of these equal to 0. X plus 3 equals 0, x minus 1 equals 0, and solve them. What would you get for the first ones? X equals negative 3, and x equals 1. By subtracting 3 or adding 1. Okay? Now, here's what you just found for me. If I put that on the graph, negative 1, 2, 3, make dot, positive 1, make dot. You just found me 2 of the 3 dots we need. In order to get the axis of symmetry, it's halfway between there. So in order to get halfway between, what's negative 3 plus 1 divided by 2? Close. Negative 3 plus 1 is negative 2, and negative 2 divided by 2 would be negative 1. So that means, right here, halfway through, should be where the axis of symmetry is. Now, in order to get where the vertex lies, plug negative 1 into your original equation, and let's see what we get. So negative 2 times negative 1 plus 3 times negative 1 minus 1. Simplify inside first. What's negative 1 plus 3? 2. What's negative 1 minus 1? Negative 2. And what is negative 2 times positive 2 times negative 2? 8. 2 negatives will make it a positive. So up 1, 2, 3, 4, 5, 6, 7, 8. Make dot. How many dots do you need? 3. You just made a parabola. Okay, do you want me to do another one like that? Huh? Yes? Okay. So, Reagan, pick a number between 53 to 56. 54. 54 has y equals x plus 1, x minus 3. So, to answer Keely's question one more time, is this in vertex form? Is this in standard form? Is this in intercepts form? When you see the 2 parentheses, it's a giveaway. It's intercepts form. Okay? So, first thing that I would do, set each of them equal to 0. And solve. So if I subtract 1 to both sides, I get x equals negative 1. And if I add 3 to both sides, I get x equals 3. So, negative 1, make dot. 1, 2, 3, make dot. Halfway between those should be my axis of symmetry. So if I take -1 plus 3 and divide it by 2, what number comes out? 1. Because -1 plus 3 is 2, and 2 divided by 2 is 1. So that means an axis of symmetry is running right down at 1, right down the middle. Is everybody okay with this step so far? Then in order to get where the vertex is, you plug in the number 1 and see what you get. 1 plus 1, 1 minus 3. What's 1 plus 1? 2. And what's 1 minus 3? And what's 2 times -2? -4. So that means it's down 1, 2, 3, 4. I make a dot on that axis of symmetry. And how many dots does it take to make a parabola? 3. Do you have 3? Yeah. So, I know like Regan, I know you asked for another one. Does that make sense? Okay. Any other ones? Are you guys okay with that?
Yep.
All right. So, here's what I got for you today, if I can find it. On page 62 to 63. It's going to seem like a lot right away, but it's not. 39 to 48, multiples of 3. 54 to 63, multiples of 3. And then 73. So when you look at that, I know it seems like a lot, but 39, 42, 45, 48, that's 4 from the first group. 54, 57, 60, and 63, that's 4 from the second group. And then 73 is a word problem. Okay? Sorry I didn't give you any time. That's because you guys asked like a half hour's worth of questions. Probably. That's okay though.
I'm just kidding.
Did I get in there, Zane? You're trying to take a picture of it. Did I photobomb it?
Hey, probably just not do it and come in and ask. I don't usually like you to get there.
This one's not bad.
Oh my gosh. I just want to.
Hasta la bye-bye. I didn't even take the attendance. That wasn't even marked anywhere. I haven't taken attendance yet, so. Okay. No worries. Good luck tonight. Play hard. Spike well. Set well? No, I don't know what are you? Okay, so you're not.
But I just follow you.
Oh, okay. Now I thought about it, that we might do, if it is like, so I thought.
That's why I didn't get. I couldn't find the case. Because I was like, I'm gonna find the case. And I was stuck in my neck and I couldn't find the case. So I was like, do it now. We can talk over this. No, we actually can't. Why is that? We can't video chat. Not chat. No, you can't.
I could not do the last floor. What was the last one? I don't think I could either. Actually, wait. I don't know. Oh, that last one, I don't know if I did it right. I just put in the fraction to the equation. I got weird numbers. Yeah, because I got like 0.6. That's what I got. 4, negative 5. No, I got 4/5 and then comma negative 5 from 8.
Their homework.
What?
I said fuck that homework.
You didn't do it?
Oh no, I did it. At like 12 o'clock in the morning.
What'd your group do?
We're doing a talk show.
Yeah, we're doing a game show.
Aaron is like really good at
Acting.
yeah, apparently so.
Yeah.
So ask her email. It's gonna work out too well.
Yeah, she's into playmakers and stuff, so.
I don't know where to find, like, I know where to find the Vertex.
Like after front of Vertex, I have to look back at like examples.
Yeah. But we only got like 2 minutes or less than that.
I sound like my mom. She's always wearing flip-flops. And I look like a hobo. I'm just really comfortable, so I'm not mad about it. I did all of them except all the ones after 20.
Oh, so that's not all of them.
It's like 2.
That's it 2.
2 problems I didn't do.
Oh yeah. So you didn't do 24, 27, 30?
Yeah.
Yeah. So probably 22. Probably
I think I got like really stuck at it.
Oh,
I did like the whole homework wrong and then I had to redo it.
number 30 is probably both.
Yeah,
I feel like everyone did that one.
I looked at them and I was like, yeah, right. I'm not gonna do that. It's too late and I don't know.
Negative 3.
I mean, he goes over the whole homework and he's like,
Okay, so
whatever
after,
problem hop on.
after you find like the negative b or whatever, and then you multiply it, and then you plug it back in, that number that it gives you, what does that do?
What now?
So like after you do this stuff, like you plug it in like this, after you do all that and you find the vertex, right? And then you plug that back in for x, what is this number?
That's X.
This is x?
Yeah. Wait.
I'm confused.
that's why we can ask questions.
Oh wait, I'm on the wrong one.
I,
Oh no.
huh?
Did you get contacts?
No, they're right here. My glasses.
Oh.
I have them, but I don't like them.
Can you see?
No,
Then why not wear them?
because I don't like them.
Why?
Because they bother me. I'm gonna wear them for the pep rally though, so I can see. You know, my flyers have a lot of trust in me because I'm blind as a bat, and they like still trust me to throw them in the air. That's trust.
That's what my sister was when she cheered for UND. She was a flyer. My sister's tiny.
I used to fly.